Hi there, my name is Eetu Jutila, and this video is the presentation of my master thesis titled as Land Cover Change Detection Using Sentinel-1 Satellite Images. This thesis was supervised by Miina Rautiainen from Aalto University and advised by Markus Törmä from the Finnish Environment Institute, Syke. The research question for my study was: can the land cover changes detected from Sentinel-1 time series be used as a clue information during the update process of the topographic database? Topographic database is the main source for land cover and land use information about Finland, and it's maintained by the National Land Survey of Finland and updated yearly. The goals for this study were that I wanted to create a well-performing change detection method and to evaluate the feasibility of the applied SAR image mosaics for the change detection analysis. The satellite data that was used in this study was Sentinel-1 SAR image mosaics that were produced in the Paikkatietoalusta-hanke earlier, and I used mean and max cross-polarized images from May to September from years 2020 and 2021. The training data is visible on the down right corner of this video, and it consisted about earlier change detection results. The study was conducted by Markus Törmä and was based on optical Sentinel-2 images from the same pilot areas as this study. And those results were then combined with the hand-labeled other targets visible on the map. All the analysis was conducted in the CSC's Puhti supercomputer via its web interface. Thanks a lot for CSC for making this study possible. The change detection workflow consisted of about 6 steps. At first, the SAR mosaics were stacked into one multiband raster. Then the labels of the training data and the cropped multiband raster was used to create features and labels for the training. Then the different classifier types were trained with the previous data, and then the changes were predicted for the whole region of Uusimaa. After that, the small areas that were classified as change pixels were removed with GDAL, sieve, tool, and finally the results were visually validated. Here's the list of the applied classifiers that were used in this study. I experimented with random forest classifiers, stochastic gradient descent classifier, gradient boost, support vector machine classifier, fully connected neural network classifier, and also with these so-called machine learning pipeline optimizers that are called Teapot and Autokeras. And on the right-hand side is an example of this optimized raster classification pipeline that was created with Teapot. It consists of MLP classifier, actually 2 of those, and then a key neighbors classifier at the end. The first results of this study seemed pretty solid. The validation results were good. but then I noticed problems with different Sentinel-1 tiles. That if the image from in the mosaic is taken from a different Sentinel-1 tile than that was used in the training dataset, it caused a significant number of false positive errors. To overcome this problem, I decided to create so-called yearly mean mosaics from the images from year 2020 and 2021. These were averaged separately and then combined into a two-band raster dataset that was then fed to the classifiers. And before predicting the results, they were also trained with this two-band dataset. And on the bottom of the screen, you can see results from random forest and autokeras classifiers with this two-band dataset. And the performance is now better, but the validation scores are lower, but still promising. However, there still exist so many errors that I think these results are not useful during the update process of the topographic database. But nice thing to note was that the large-scale change detection is possible with the two-band raster dataset. All right, then let's move on to the learning process. That was thrilling, especially the complicated theory behind SAR images was a nice thing to learn. And I also noticed that there exist many different change detection methods, ranging from really simple ones to actually quite advanced and complicated ones. And this was also my first own machine learning project where I could define every parameter myself and from the scratch. And this process was also good for academic writing that I think I got quite good at the end of this project. But yeah, that was my thesis in wrap. Thanks for your attention, and thanks for the Mina and Markus for the advising, and to my partner for her patience. Thank you.